Good morning everybody. Today we are going to discuss about the operating point and DC load line of a transistor. The operating point of a transistor is very important for the application of a transistor in different purposes. So the concept of the operating point is very important. What do you mean by operating point of a transistor? Actually, operating point of a transistor means where the transistor is acting. That means how much current flowing through the transistor and how much voltage appear across the output terminal of the transistor circuit in absence of the any input signal applied to the transistor circuit. Okay, if we superimpose the DC load line of the transistor circuit with the static output characteristic, the intersecting point of the DC load line and the static output characteristic gives the operating point. Okay, so to understand the operating point, we have to know about the static output characteristic and DC load line. So let's see the circuit diagram where a transistor in C mode configuration connected in the circuit. Why it is called C mode configuration? We already have discussed in the previous classes about the transistor, and there are three terminals. This is base, this is the emitter, this is the collector, and there are two loops in the circuit. This is the input loop and this is the output loop. Okay, and in both the loop emitter terminal is common, so it is called common emitter. Okay, and here the input current is the base current and output current is the collector current, and this is the output voltage. So if we draw VC versus IC for different value of IB, then we get the static output characteristic. So this is the static output characteristic. Here we have drawn VC versus IC for different value of IB, and to get the family of the curve, here we have chosen different value of the base current. For IB is equal to 10 microamp, we get this curve between VC and IC, and for 20 microampere and for 30 microampere. Okay, and when base current is 0, when the base current will be 0, when the input junction of the transistor remain in the reverse bias condition, and this region is called the cutoff region, and the transistor acting in that region. When the transistor is acting in that region, when the transistor is acting in that region, when both the junction, base to emitter junction and collector to emitter junction remain in the reverse bias condition. Okay, and in that region the collector current almost 0. We get very small amount of current due to the minority carrier, but most of the cases we neglect it. So the coordinate of the cutoff region is VC may be any value and the collector current IC almost 0. So this is the coordinate of the cutoff region. Okay, this is another region. This is the saturation region, and in that region VC almost 0, very very small, VC 0 and IC may be any value. The transistor acting in that region, saturation region. When the transistor acting in the saturation region, when both the junction, base to emitter junction, this is the input junction, and collector to emitter junction remain in the forward bias condition. The transistor acting in the saturation mode, when both the junction, base to emitter junction, collector to emitter junction remain in the forward bias condition, then the transistor acting in the saturation region. And we can use transistor as a switch in that two region, cutoff region and saturation region. We operate the transistor in that two region. For open switch, transistor is operated in the cutoff region, and for the on switch, closed switch, transistor is operated in the saturation region. And another very important region is called the active region. Actually, the transistor is acting in that mode. This is the normal operation zone of the transistors, active region. And in that region, transistor behave as a linear. So, for the amplification of a signal, transistor is operated in the active region. And when the transistor acting in the active region? When the input junction remain in the forward bias condition and output junction remain in the reverse bias condition, then the transistor acting in the active region, and transistor behave as a linear. Actually, transistor is a non-linear device. But if we operate it in the active region, then the transistor is behave as a linear. And so, transistor when used as a amplifier, transistor acting in the active region. Okay, see the transistor behave as linear, so the amplification will be undistorted and also stable. Now, I will talk about the DC load line. If we apply the KVL equation to the output loop, here the supply voltage is VCC and the collector current is IC, and this is the load resistance. So, what will be the KVL equation? VCC equal to IC RL plus VCE, okay, or IC equal to minus VCE by RL plus VCC by RL. In the equation, VCC is constant, the constant supply, RL is also constant. Here only the variables are IC and VC. So, this is the equation of the straight line. And if we compare it with the equation of the straight line mx plus c, then we get the slope of the straight line m is equal to minus 1 by RL. So, the slope of the straight line is 1 by RL. What is RL? It is load resistance. Okay. So, from the slope of the straight line, we can calculate the load resistance. So, it is called the load line. And if we superimposed this load line with the output characteristic, first I will show you what are the points through which the straight line is between which a straight line is drawn. Okay, let's show. If we take IC is equal to 0, for IC is equal to 0, VC is equal to VCC. So, this is the one point of the straight line. We know for drawing a straight line we need 2 points. So, this is the one point, and for another point we have to choose VC is equal to 0. What will be the value of the IC for VC is equal to 0? IC will be VCC by RL. So, this is another point. So, these are the 2 points through which this straight line is drawn. Okay, and where is the point? IC is equal to 0. Where IC is 0? IC is 0 in the cutoff region. So, one point remain at the cutoff region, and here VC is equal to 0. Where the VC is equal to 0? In the saturation region. So, this is another point. So, the straight line is remain between these 2 points. One point remain at the cutoff region and another one remain in the saturation region. So, if we superimpose the straight line with the output characteristic, then we will get just like that. So, this is the DC load line and this is the static output characteristic, and these are the intersecting point, and the coordinate of the intersecting point gives the value of the collector current and the collector to emitter voltage, output voltage. So the intersecting point of the DC load line and output characteristic gives the operating point. So this is the operating point. This is another operating point. This is another operating point. But for the amplification action of the transistor must be operated at the middle point of the active region for stable amplification, for undistorted amplification. So to establish the DC operating point at suitable location, we need proper biasing. Okay, and I will discuss the biasing. There are different type of biasing, and I will discuss the biasing in the next class. Okay, thank you.